Morning, everybody. My name is Ferhat Sadak. I'm an assistant professor at Bartın University, Turkey. Today, I'm going to talk about I can't see the full. Okay, talk about enhancing insect population monitoring through imbalanced dataset handling techniques. The SDSM that I conducted with Chantal Neighbours from Naturalis Biodiversity Center. Here is the brief outline that I'm going to talk about it. So basically, the aim of my STSM was to enhance insect population monitoring by addressing the challenges of imbalanced dataset using advanced machine learning techniques. For this purpose, the specific objective was to evaluate various class imbalance handling strategies using efficient net version to medium-sized model as the base model and assess the impact of the models that we try on the model performance by looking at the test accuracy, precision recall, and F1 score, and address the issue of imbalanced insect population data sets where certain classes are significantly underrepresented. So here is the dataset that I use from Naturalis Biodiversity Center. As you can see, the dataset is highly imbalanced. For some class, they've got 1, 2 images, 3, 4. Some class has got around 10, while some class has got around 100, 10,000, even 1,000, even 10,000. So in total, the number of image for this dataset is 39,445, distributed across 72 classes. And 70% of this data was used for training purpose, and 20% of this data was used for validation, and the remaining 10% was used for testing purpose. So here is the strategy that I follow. So basically, efficient net version 2 medium-sized model was used as the base model and yielded around 67% test accuracy. And then we use weight balancing, oversampling with data augmentation, SMOTE and edited nearest neighbor, SMOTEENN, SMOTE with Tomek links, SMOTETomek, and KMeansSMOTE. Since SMOTEENN and SMOTETomek has demonstrated the superior performance compared to baseline model, so the presentation will focus on these two methods. So basically, SMOTE combines synthetic minority oversampling method with edited nearest neighbor. Basically, SMOTE generates synthetic samples for minority classes by interpolating between the existing ones, while edited nearest neighbor removes the noise and refine the class boundaries. SMOTETomek also uses SMOTE for generating synthetic samples combined with Tomek links, which are the pair of samples from different classes that are close to each other. So in that way, removing these pairs helps to clean the data, remove the noise, and have the better class boundaries. So basically, these are two hybrid methods that does oversampling and undersampling. So here, the green bar shows the original model, efficient net version 2N. The orange bar shows the results with SMOTETomek, and the blue bar shows the result with SMOTE. As you can see, for the majority of the class, we received the higher F1 score, either with SMOTEENN or SMOTETomek. And this can be seen in details for each class that we have. Even if we have around 4, 5, 6 samples from a certain class, either SMOTEENN or SMOTETomek has demonstrated better performance here. So basically, definitely we have improvements with SMOTEENN, with hybrid techniques, either with SMOTEENN or SMOTETomek. And we address the imbalance by generating synthetic samples and refining the decision boundaries. Interestingly, for certain classes, not a lot, just a few, we have also had high F1 scores without any sampling techniques. This suggests that the classes have distinct features that the model exploits effectively. So these pie charts demonstrate the distribution of classes by highest F1 score across models. So for the 37% of the classes, we didn't have the winner for the F1 score. That is actually a bit misleading because some class has got 1, 2, 3 images, and I didn't include those if they have less than 3 images per sample, per class. That's the reason why this number is a bit high. And for 1.5% of the classes, we received the highest F1 score by the original model. And for 27% of the class, we have received the highest F1 score by SMOTEENN. And finally, for the 35% of the classes, we have received the highest F1 score using SMOTEENN as the imbalance strategy. So the best accuracy we receive by SMOTEENN and SMOTETomek, they are really close to each other. It is 75%, so almost 8% increase in accuracy by using these strategies. We also have strong baseline performance for select classes for FU. And that means oversampling is not universally required. It might not be required, actually. So the key takeaway from my STSM, I would say no single method works best for all class. And SMOTETomek excels in refining the boundaries especially for overlapping pictures, while SMOTEENN is more effective for noisy data. And considering the dataset that I received from Naturalis Biodiversity Center, it was quite noisy. So I would say SMOTEENN was more suitable for our case. Yeah, this brings us to the end of my presentation. Thank you very much. I would be happy to answer any questions you may have during the question and answer session. Thank you.